Cost method, right? Okay, so you know how to arrange your frame. What should be here? 3n squared followed by plus 7 and followed by plus 10n. So what and what will give for 3n squared? 3n and n, okay. And what will give us 7? 1 and 7, okay. If we were to do this, when we cross multiply, we will get n here and this will be 21n. Is it possible for us to get 10n? Then what will we do? 7 on top and 1 below. Okay, so we switch the position now. Okay, so we will then be able to get 7n over here and 3n over here. And it's possible when down here, what sign? Plus and plus. Okay. And also this is how we then get the answer of this. Okay. Next, question 7e. Right? af squared plus 4f minus 60. What should we do? Say what do you do? What should we always do first when it comes to factorization? Find common factor, so is there a common factor? There's a common factor of 2, right? So we should take that out first. So 2, and then we left 4f squared plus 2f minus away 3, 0. But is there still a common factor? Yeah, we should actually take out 4, right? Okay. So if we were to take out 4, we will be able to get this. Then now we focus on doing the cross method on 2f squared minus 15 plus 2f. Okay, so we have 2f and f here. Maybe 5 and 3. Huh? Okay, sorry. Thank you. Okay, so maybe 5 and 3. Alright, 5f, 6f. Okay, so we will have positive minus sign minus plus. Right? And we will then have 4 times 2f minus 5 and f plus 3. Okay, that will be 7e. Right? Next we look at question 8. I'm looking at textbook page 73, by the way. It says that there is a rectangle. Okay. So I'm drawing out a diagram to understand the question. With a length of 2x minus 3. So the length is 2x minus 3 centimeters. Okay. The area is actually 4x squared plus 8x plus 15 centimeters squared. That without factorizing the expression, explain if the ref of the rectangle can be x plus 5. Okay, so the question is, can ref be x plus 5? Cm without factorizing. Okay, so the key thing here is without factorizing. But maybe we think about why is it they stop us from factorizing? Okay, because they give you the area, rectangle itself, how do we find the area? What's the formula? Length times breadth, right? So if I know the length and I have the breadth, okay, I'm able to multiply to get the area. In other words, if I can factorize this area into 2 separate factors, one of them must be 2x minus 3. The other one will actually be the ref. Okay, so but then the question stops us from factorizing. Then they want us to determine, okay, whether the ref would it actually be x plus 5 cm or not. Okay, so we think about this, right? What if the ref is x plus 5? Okay, so if the graph is going to be x plus 5, that means if I were to take 2x minus 3, multiply with this graph x plus 5, okay, I expand it, I need to get this area, correct? Okay, if I take this length and this graph, I expand it, I'm going to get the area. Now how do we do this expansion? Okay, so by right, if I expand, right, I will be able to get this, right? But based on our expansion method, we know that we're going to take 2x multiplied by x, right? 2x multiplied by x. But what is 2x multiplied by x? 2x squared. Immediately at this stage, can we already confirm that x plus 5 is not going to be the area? Yes, right? Because what is in the area? 4x squared. Okay, there is no other way for us to do our distributive law, our rainbow method, okay, in order for us to achieve a x squared term. Because in this manner, 2x times 5, I'm actually getting a plus 10x. Okay, negative 3 times x, I'm going to get a negative 3x. And then negative 3 multiplied with positive 5, I'm getting a negative 15. Okay, so I don't even need to bother with extending it fully, right? Just by observing this particular way of multiplying itself, immediately I can tell that, okay, I'm going to get 2x squared, which is not the 4x squared term already. Okay, so how do we explain this? You cannot write it this way because it's mathematically incorrect in the first place. They are not equal. Okay. So what we can just say is that, right, when 2x and x multiply, it achieves 2x squared, which is not 4x squared. Therefore, x plus 5 cm cannot be the graph of the rectangle. In this particular unit, we have been looking at using these formulas that we have previously learned, alright, for factorization purposes. Okay, and in factorization, we are looking at this direction from the right side to the left side. Okay, so I did mention also that it is not always compulsory, okay, for us to actually use these identities, right, for us to do factorization. Okay, because we can use cross method instead, right? But it is actually helpful, right, for us to still learn this method because when our numbers are in fractional form, okay, it might actually be easier. Or rather, maybe there is lah. Okay, let's discuss it. Okay, so looking at practice now 19. Sorry, 9. Next, page 95. because the highest power is a 2. Okay, so with 81x squared minus 16, if I want to use my cross method, how will it actually look like? Okay, so I'm trying to use the cross method, the method that we all already know. Okay, how it looks like is that in my cross method itself, I know that this part here must be the one with power of 2. Okay, down here must be the constant term, and then down here is the one that is power of 1. That was what I understand about cross method. But that isn't. Okay, so what am I going to write over here? Okay, actually, it is just that it is not clearly written out. It is a plus 0x. Okay, so you will write here a positive 0x. Because 0 times x is 0, 1. We usually don't need to go and intentionally write in the plus 0, right? Okay, so if I were to use the cross method, this will be how it looks like. Okay, then we need to decide what transform will give us 81x squared. Maybe we do a 9x and 9x. Okay, and then for 16, maybe we do a 4 and 4. Right? Then we cross, we get a 36x here, and then a 36x here also. Okay, yes?
Minus 16.
Minus 6. Minus 16. You're trying to answer a question, is it?
No, because you know it's not 4 times 4 is like
4 times 4 is?
positive, right?
Yeah, but my signs are determined later on. So my signs here will have to be a positive and a negative in order to give us a 0. Okay? So then after that, here will be positive and negative. So positive times negative will give us negative 16. Okay? So then my factorization will actually be 9x plus 4 and 9x minus 4. Okay, this is if we were to use our cross method. But is it actually necessary? Okay, so the method I want us to learn is how will this formula help us? Right? This will, in fact, learning this will help us do it faster. We don't even need to go through this cross method because 81x squared minus 16. We recognize that 81 and 16 they are perfect squares, right? And 81 is a perfect square of 9. I can write it as 9x bracket squared. And 16 is a perfect square of 4. Okay, and we have 4 squared. So if I were to compare this with my a squared minus b squared, I am trying to recognize that a is going to be 9x and b is equals to 4. So I'm doing a parallel matching up. Okay, it must be with brackets, right? Because this square here belongs to x, while this square belongs to 9x due to the brackets. So with this recognition, apply our formula here, I will then be able to say that it will be 9x minus 4 times 9x plus 4. It doesn't matter whether the plus comes first or the minus comes first. Okay, because you can shift it around and it still holds true. Okay, so this is a minus b, a plus b. Questions? Okay, maybe let's do another one, just to do an additional one. Okay, so just give it an extra one. Okay, not for your textbook. What if we have maybe 36 minus away 25 b squared? Okay, how will we then use our formula here? Any tries? Anyone? Yes, you go. 6, 5, so what do I write? Okay, but then? Sure. They equal, man? Brackets? Brackets around 6? Sure. equivalent. Okay, must match part by part. Alright, so we get 6 square minus away 5b bracket square. Okay, and in this form, we recognize that a is equals to 6 and b is equals to 5b. Okay, and hence, using our identity, I will be able to conclude that it is 6 plus 5b, 6 minus 5b. Okay. Understand? Right, so it actually isn't necessary for us to do cross method at all. We see that if I can recognize my perfect squares and recognize this a square minus b square, okay, it will be much faster for us to do our factorization. Okay, so this will be the way to go when it comes to two terms and yet quadratic. Okay. Next, we look at part B in this textbook. What if I have negative 25y squared plus 9? Okay. How do we factorize this using what we have learned? I'll call out her name. Let's see. Alisa. Zero. Yes, zero. How will you solve this? Sorry? Factorize out the minus. Okay, so according to zero, she will factorize out the minus. Okay, and then we'll get 25y squared minus away 9. Right? And then after that, what? 0, can we continue? So what? What do we do next? Bracket 5y squared. Like that. I leave the negative sign outside. Okay. Then minus 3 squared. Okay, so we see that our a is going to be 5y and my b is equals to 3. Okay, because a squared minus b squared. Okay, then continuing, I will continue my negative sign, and this will give me 5y minus 3, 5y plus 3. Okay, because a minus b, a plus b. So the negative sign that was factorized out is to continue on. Okay, to be there. Right? Does anyone have an alternative? Yes, Kelly? Sorry, just what? Flip it. Okay, actually that is an easier way out without doing the factorization, and that was to just rearrange the terms. Right? Okay, because we agree that negative 25y squared plus 9 is equal to 9 minus 25y squared, correct? Okay, so then you will see 3 minus away 5y bracket squared, which is the same as 3 minus 5y, 3 plus 5y. Okay, they are actually equal because if I were to bring this negative sign inside here, okay, inside this bracket, I'm going to get negative 5y plus 3. And that is actually this term. So they are actually equal. So both methods are acceptable. Okay, just that you need to know how to manage, alright, what you have decided to do. Okay. Questions? Right? If not, I want you to try out part D, E, and F on your own. Okay. So part D. 4a squared minus 64b squared. This is part B. answers first. Oh, I also look at them. Until later on she reflected on it, alright? Then after that she saw that there is still common factors. So always remember to check whether there's common factors or not. Which explains why the first thing that we should always do in factorization is to check for common factors across all the terms. Okay? Because if that was actually observed right at the beginning, okay, that there is a common factor of 4, then we will be left a squared minus away, a squared minus away 4, 16b squared. Right? Okay, if a factor of 4 was taken out. Right? So then we get a squared minus 4 squared, 4b squared. Okay? Okay? Let me adjust my brackets. And then we will get 4 times a minus 4b, a plus 4b. Okay? Now, if you had done the same way as what Hwk Ch did, okay, she actually initially took out a 2 instead of a 4. And that's not correct. Okay, because 2 is being taken out from this first set of brackets, and another 2 is also taken out from this set of brackets. So actually it's 2 times of 2, and that will actually be 4. Right? So therefore the answer should be 4 times a minus 4b, a plus 4b. Okay, so I will take it that the answer is correct. So 10 points. Alright? Now we take a look at part E. Okay? The answers from Rose and Brandon are very different. Okay, they approach it in a different manner. Right? Maybe I start off with what Brandon has done. Okay? What Brandon has done is that he knows that 8 over 25 is not a perfect square. Neither is 18 a perfect square. Okay? So he took the approach of factorizing out common factors first. Okay? He saw that there's a common factor of 2, and that leaves him with 4 over 25, which is a perfect square, and 9, which is also a perfect square. Okay? Then now he is able to write it as 2 over 5b bracket square minus away brackets 3a squared. Okay? I hope the people at the back can see this. And right? Okay, then after that he applied the a plus b, a minus b identity, keeping in mind that the 2 stays outside. So his method is correct. Okay, although it took him a few iterations of changes. Okay, so after reviewing whether he can entrust his life with Matthias, right, he gave this to us. So you come up with this after you don't want to entrust your life to Matthias. Okay. Then who do you choose to entrust your life to?
Not life,
not life, okay. Thank you for the clarification. Okay, now let's look at Rose's approach. Okay, Rose's approach is that she wanted, okay, to create the perfect square, right? So she decided to multiply by 2 across the entire expression, but it does not make this statement and this statement equal. Okay, so they are not equal. So she actually, I saw that she originally wrote equal sign here, but I thought she can erase it away. Okay, so they are not equal. You cannot just times 2 randomly. Right? And when we multiply by 2 to the original numbers, what came out of it is that 8 times 2 will give us 16. Keep in mind that 8 over 25, a fraction, multiplied by 2, okay, 2 is actually 2 over 1, numerator times numerator, denominator times denominator. numerator. So you cannot times 2 to the denominator. Okay, so do keep that in mind. Okay, so we get 16 over 25, and then 18 times 2 we get 36. Okay, so at least that is being done throughout the entire expression. Alright, then after that, now that she achieved perfect square, she can see that 16 over 25 is the square of 4 over 5, and 36 is the square of 6. Okay, so she re-expressed it in this manner, and using this approach, she actually gets this. Okay, she got 4 over 5b minus 6a times 4 over 5b plus 6a. Right? And then, this is the factorization for this thing. It isn't for the question. So because there was a multiplication of 2 at the beginning, okay, she bear that in mind and then divided by 2 at the end. Okay, so this answer itself, alright, I would say that mathematically it is accurate, but maybe not an approach that I would have taken. Okay, and I also find that it could be a little bit contentious whether is it fully factorized or not, because actually 4 over 5 and 6 there is a common factor of 2 lah. Okay, in the numerator. Right, but I'll accept this answer. Okay, so points do go to Rose and Brandon. Alright. Right, but I think that Brandon's method is more efficient, okay, and neater as well. Okay. Questions for part E? Now we look at part F. Okay, part F we have 4x plus 1 square minus 49. Okay, and also we see 2 approaches from Katie and Emmanuel. Okay, let me just write the name here first. Alright, so what Katie has done is that she observed that 49 is 7 square, and then this becomes the A, and this becomes the B in my A square minus B square. For which she then applied the formula to get A plus B and A minus B. Okay? And that simplifies 4x plus 1 plus 7 and 4x plus 1 minus 7, which then leads us to 4x plus 8 times 4x minus 6. Okay? And then thankfully she checked that there is common factor in each of the bracket. This has a factor of 4 inside, and over here there's a factor of 2. Okay, so she could have done 4 times x plus 2 for the first set of brackets, and then for the second set of brackets, factorizing out a 2 to get 2x minus 3. So it can be done concurrently lah. Okay, and that leaves us with the answer of 8 times x plus 2 times 2x minus 3. So this is great because we can see the very clear application of what we just learned. Okay. For Emmanuel, answer achieved is actually the same as well, is it? Not really, okay. But the method that he has taken was to do the expansion. Okay? And I think Xavier just now corrected him that this 4x plus 1 bracket square needs to be expanded to this by using this formula. So that might be an approach that some of us take. Can I check how many of you decided to do the expansion approach? Okay, I also am aware that many of you didn't know how to do. Okay, so by expanding, we get this and simplifies to 16x squared minus 48 plus 8x. Then he took the cross method approach, okay, getting this 4x minus 6 times 4x plus 8, for which you notice this one has a factor of 2, but he forgot to check the other bracket. 4x plus 8 also has another factor of 4. Oh, sorry, you did notice, but then it is not correctly done also. You take a factor of 2 here, or factor of 2 here, it needs to become a 4 actually. Yeah, but even so, this one is not fully factorized either. Okay, so it should have been another 2 coming out, so 8 times 2x minus 3 and x plus 2. Okay, right, yes, Emmanuel. Emmanuel, yeah, Tracy. Sorry? Factorize that from here, yes. Yeah, so actually from here, you notice there's a common factor of 8, then after that, do the cross method, that's by itself. Okay? Questions? Alright, so I'll give Eileen 20 points. For the slight inaccuracy for Emmanuel, I'll give 15 points, okay? Alright, let's square minus 9. Okay? So how can we evaluate this without using a calculator? Right? We observe that 9 is a perfect square of 3. So we can write it as 103 square minus 3 square. And that will give us 103 plus 3 and 103 minus 3. Right? We agree that 103 square minus 9 is difficult to calculate mentally. I also wouldn't know how to calculate it mentally. 103 times 103 itself is a big challenge. Okay? So 103 plus 3 will actually give us 106. And 103 minus 3 will give us 100. And this is definitely much easier for us to calculate now because it's just 106 with 2 additional zeros at the back. Right? Okay, what will you do? Let's call a D. Okay. I think Faith looks like it's over. Faith, can you tell me how will you approach this by using what you saw just now? 121 is a perfect square of because Asher told you. Alright, so what do I write? As in right here 11 square, then down here 121. I'm supposed to follow through right now. You see, you tell her the answer, she don't know why you do that. Yeah. So why is it 11 square? Square of 121, yes, it's 11. Then it's 211 square, what happens to it? Bracket. Okay, tell me from the start what will you write? What do I write? Just read out. 211 square minus 11 square. Okay, read again. Next line, okay. Bracket. Bracket 211. Minus 11 square, like that. Sorry, did I catch it correctly? 211 minus 11 square. Then another 211. I don't know what you want me to write. How do we apply it there? What should I write next? Bracket 211 plus 11. Okay, bracket 211 minus 11, and 211 plus 11 is equals to 222, and 211 minus 11 is 200. And can you solve this mentally? Okay, great, thank you. Alright, so are we able to get it? Yeah. Right, I won't go into part C and D because it's kind of the same idea. I hope you all get an idea already. Okay. Unfortunately, I have still one more question. I think I will just save it for the next lesson. Next lesson, make sure you finish your SLS before that already. Then do prepare for for your home-based learning